Hi, everyone. Thanks for coming to my talk today. I know it's been a long week, so I appreciate you being here Friday morning. My name is Victor Bhattacharya. I'm a product engineer on the geocoding team, and today I'm here to talk about high-performance batch geocoding with ArcGIS. So the goal of this presentation is to get the best possible batch geocoding performance from your system, whatever that looks like, be it desktop-only geocoding, whether you have ArcGIS Enterprise set up, whatever that looks like. Here's a quick outline of what I'll talk about today. First, we'll give a batch geocoding overview. Then we'll talk a little bit about the desktop geocoding recommendations, and then ArcGIS Enterprise geocoding recommendations, and then working with clients for ArcGIS Enterprise. So let's get started. First, the batch geocoding overview. So batch geocoding. Fundamentally, what is geocoding? It turns addresses to points on a map. Batch geocoding specifically is doing this for large tables of data. So here you'll see that we have a table. We can use one of the batch geocoding tools in the geocoding tools box in ArcGIS Pro, and we use the search engine that is geocoding to put those points on the map. And geocoding is sort of fundamental for GIS analysis. It's the first step in getting your data into the system so that you can run some analysis on it. So addresses, your data. Let's talk a little bit about what that looks like. Addresses in general are hard to control as a data type. You might receive a CSV or an Excel file from someone else in your organization that you have to work with. Addresses change over time. New roads get built, new housing developments go up, new restaurants open, reference data changes, which is why we recommend, whatever your data may be, we recommend that you rebuild your locator based on the latest reference data that you have available. And ideally, the batch geocoding approaches that I present today must fit the need for any scale. So if you're geocoding maybe a spreadsheet of 100 addresses, or 10,000 addresses, or 100,000 addresses, or 10 million addresses, I want to show you how to do all of that today. If your addresses are in multiple columns, or multi-field, let's say you have an address field, a city field, a state field, and a zip field, we can do batch geocoding there. We can also do batch geocoding against a table with all the fields concatenated into a single column. All of our clients have the ability to do batch geocoding, whether your data is multi-line or single field. Geocoding in ArcGIS Pro. So what does that look like? Pro ships with some default locators, specifically the World Geocoding Service. This requires the internet, and if you perform batch geocoding against the World Geocoding Service, this will consume credits. There's also an XY provider that comes in the box for coordinate and grid handling. Now, the locate pane is what defines your available locators. So you'll see I have highlighted the little plus bar. So in the locate pane, if you go to the settings tab, you can add more locators there to your Pro project. And these locators might be local on disk. They might be locators that are shared to your portal. Just really depends on what you want to geocode with. Once you click that plus button and enable that locator for geocoding, you'll start to receive suggestions and geocoding results from that locator, which is the bottom image. So you'll see we've typed 380 New York Street, and we're getting suggestions from multiple locators that we've configured in ArcGIS Pro. Locator options in ArcGIS Pro. So you have sort of two options. You can build your own locators using the Create Locator tool, which is in Pro 2.3. We recommend that you use the Create Locator tool for the best possible performance. And we also have Esri provided locators. So there's the World Geocoding Service that I already talked about, and you can always also purchase World Geocoder for ArcGIS and StreetMap Premium locators. And that's nice because they come out of the box and you can stand them up in your enterprise organization and work with them. All right, so that was the batch geocoding overview. Let's talk a little bit about desktop geocoding recommendations. So if your locator is local and your data is local, this is the slide you guys are going to want to take a picture of. So this is the recommended desktop geocoding recommendations. So we recommend that you use ArcGIS Pro, the latest version, so that's 2.3. We recommend that you use new locators, so either the most recent release of StreetMap Premium locators, or build your own locators with the Create Locator tool in ArcGIS Pro 2.3. We recommend that you set the number of threads on your locator to auto. And so what auto does is that it sets the value of threads to one less than the number of cores on your machine. So this will allow you to get the best possible geocoding performance without overwhelming your client machine. We also recommend that you put your locator and your input table on a solid state drive, and we recommend that the output that you write out to is also on a solid state drive for the best performance. We recommend you use the Geocode table pane in ArcGIS Pro, and you can automate desktop large batch geocoding using the Geocode addresses GP tool. So let's dig in a little bit to that last bullet point. So automating using Geocode addresses. So you would just, ideally, probably the easiest way to get started is you would run the Geocode addresses tool in Pro, right-click on the result, and click export to Python command, and then you have a stub to work with. But this is an example of how you would call Geocode addresses. So you define where your table is on your disk, you define where your locator is, you define your field mapping, you define an output location for where you want the output feature class to go. You've noticed I've grayed out part of the path there because that was a path on my machine, but whatever the path looks like on your machine. And then we have some additional geocoding options. So if we want to restrict the geocoding output to a specific country, if we want to ask for whether it be the routing location or the address location. So routing location means the side of street location, and address location is the centroid of the parcel. So on top of your building versus where you'd want your mail dropped off. And then category, there's all sorts of categories that you can use for category filtering as well. And then you would call the arcpy.geocoding.geocodeaddresses tool. And now for desktop geocoding, it's really just dependent on the amount of cores and resources you're willing to dedicate. So back to this slide, if you have, let's say, a massive client machine, a 40-core client machine, if you can set that number of threads to 40 and get the job done as fast as possible. In fact, my manager did this and geocoded 100 million records over the weekend. So it's really just dependent on how much hardware you have and how much you're willing to devote to batch geocoding on the client side. All right, let's talk a little bit now about ArcGIS Enterprise geocoding recommendations. So this is the recommended ArcGIS Enterprise batch geocoding system. I'll talk a little bit about the advantages first, and then I'll dive into the architecture. So the advantages of this system are you get the most performance out of your enterprise geocoding services. You're able to manage your back-end resources and not overwhelm your back-end GIS servers. You can perform batch geocoding behind your organizational firewall. And this pattern has chunking and retry logic built in, which I'll talk a little bit more about in the future. Now keep in mind, this does require ArcGIS Enterprise. So this is the story for if you have ArcGIS Enterprise and you want to do large batch geocoding. Some quick system recommendations for the best possible performance. First, we recommend that you use a client that leverages this pattern. So the clients that leverage this pattern right now are the Geocode locations from table map viewer tool, in case you have a web UI that you want to use, the Geocode table pane and the Geocode locations from table tools in Pro 2.3 if you have a desktop environment, or the arcpy.geocoding Geocode locations from table arcpy call, or you could write REST requests directly against the GeocodeFile API in terms of scripting. So this is sort of a high level of all the clients that you could use to leverage the batch geocoding system that I'm about to talk about. In terms of ArcGIS server recommendations, we recommend that your server has multiple cores. Obviously, the more the better. The more cores you have, the further we can parallelize your job and the faster we can get the job done. We recommend that you have enough memory for those cores. So I believe the standard recommendation is whatever the locator size is plus 500 MB per core. We recommend that you have an SSD drive and fast processors. So let's dive in a little bit to how the system works. So before we had this architecture on the back end, we would have ArcGIS server and your client. So what you would do is when you publish a locator to your ArcGIS server, it would come with the Geocode addresses API, which is an API for batch geocoding. The way the Geocode addresses API works is that it accepts up to 1,000 records per each request input in a JSON format, and then outputs the same 1,000 records, and it would be up to you to chunk your table. So if you had more than 1,000 records, you need to grab the first 1,000, serialize them into JSON, send them to the Geocode addresses API, wait for the request back, and then stitch the results back together. This system does all of that for you. And I guess I'm in a room with a bunch of developers. So when you're making REST calls, you don't always have, there's a reliability factor, right? Whenever you're making any internet service protocol, it depends on your internet, it depends on how the server's doing, if it's overloaded. So ideally, you would build in some retry logic as well. So if you get a bad response from the server, you would maybe chunk half of those 1,000. So you'd send the first 500, send the second 500, and wait for responses back. So the pattern I'm about to describe does all of this for you behind the scenes. So instead of this main process, this is actually ships with starting at 10.5.1 ArcGIS Enterprise. So this is actually called the Geocoding Tools Geoprocessing Service. Now, let's say instead of sending one Geocode addresses API call at a time, so instead of geocoding 1,000 addresses per every request, you could geocode 4,000 addresses per every request if you apply this NumBatchThreads property per locator on your back end. So what this NumBatchThreads property says to the geoprocessing service, it says, hey, I know that there are 4 cores on this machine that are dedicated to batch geocoding, so you can hit me with 4 threads, and I'll get your job done 4 times as fast. And then finally, the ultimate job of a batch geocoding engine would be to put points on the map, right? So it would generate an output feature layer. Let's take a closer look at NumBatchThreads. So let's say I have an ArcGIS server stood up, and I've published my geocoding service to it. And I know that this server has 4 cores. It's a fast 4-core machine. And I know that I want to devote all the resources on this server to batch geocoding. What I would do is I would go into the server manager, scale up my geocoding services to min instances 4, max instances 4. So I know that at all times 4 instances are running on the server. Since I know there's 4 instances that are running that I can hit, I can put in this NumBatchThreads property so that the Geocoding Tools GP service knows that when I send batch geocoding requests to this locator, I can hit it with 4 threads and parallelize the job and get it done 4 times as fast. We have seen linear speed up with this architecture. So it's really just dependent on how many resources you have on your back end that you're willing to devote to batch geocoding. Now, it may be the case that more than one user is doing batch geocoding in your organization. Let's say you have 2 users submitting concurrent batch geocoding requests, but you still only have 4 SOCs on the back end, 4 cores available for your geocoding service. What you might want to do is set your NumBatchThreads to 2, in which case every job that gets fired off to this geocoding service uses 2 threads instead of 4. And this way, 2 users can use this batch geocoding pattern at once. It's up to your ArcGIS administrator to go in and set this number appropriately. So configuring portal batch geocoding. So all of these will have hyperlinks on them. It turns out this becomes a PDF and not a PowerPoint for you guys later. So I've actually put all the links, and I've shortened them at the very bottom. If you guys want to take a picture of this slide, I have all the bit.lys at the bottom for all of the doc pages that you might need to read to set up this system. So first, you would want to publish your locator to your server and add that locator as a utility service. Once you've added it as a utility service, it will show up in the sharing API call. And then you can set the number of threads per geocoder via the sharing API, which is the configure threads arrow in that photo. Then you would scale up your GP service based on the server resources. So if you know that you have 8 cores available for batch geocoding, you might scale up your locator service to have min instances 8, max instances 8, and then set the NumBatchThreads property to 8. And then finally, there's a sort of catch-all help topic called configure portal to geocode addresses. You can capture that via the last bit.ly, or if you type into Google, in quotes, configure portal to geocode addresses, it does give you exactly the doc page you're looking for. All right, so let's jump to a configuration demo. So how would you set up this backend architecture? So at the portal sharing API, so this is the portal self call. You would scroll to the bottom, and there's an update operation. Once you've added your locator as a utility service in your portal, it'll show up in this in the geocode service JSON. So let's grab that JSON and see what it looks like. All right, so we've got a San Diego locator. Now we want to hit this locator with, let's say, 4 threads, since we know there's 4 backend instances that we are freeing up for batch geocoding. So we'll set this NumBatch, we'll add this NumBatchThreads property and set it to 4. And then we copy the JSON again, paste it back into the box, scroll to the very bottom, and click Update Organization. And you're good to go. So important to note is the NumBatchThreads property is set per locator. So if you have multiple locators stood up on your ArcGIS server, and you have one of them configured to 8 instances and one configured to 4, you can go into the sharing API and set the NumBatchThreads appropriately for each participating locator. Let's talk a little bit about clients that leverage this backend system and allow you to do this large batch geocoding effectively. So clients for geocoding data on the portal. First, we have the Geocode table pane. So I'll do a quick demo in Pro. Cool, so we have ArcGIS Pro here. So I've got this CSV of 4,000 USA addresses. I right-click on it and click Geocode table. Then I can click Go to Tool. So let's say for this one I want to use the Esri World Batch Geocoder. Now one thing to note is we don't allow you to configure the NumBatchThreads for the Esri World Batch Geocoder, since if everyone did that, they would overwhelm our backend system. So we hard code this one to 1 thread if you're using the Esri World Batch Geocoder, which I think is probably great for you guys, since if you hit it with multiple threads, you would burn all your credits really quickly. So I will spare you guys. This is normally where I tell my programming jokes, but I know it's been a long week. So I'll do a quick time warp, and we will see these results on the map. So when you click the locator that you're choosing for batch geocoding, as long as that locator is enabled with the NumBatchThreads property, you'll see this speed up. And there you have it. We have 4,000 points on the map. So you can continue doing your analysis from there. There's also a tool in the ArcGIS Enterprise map viewer that you can use to leverage this asynchronous batch geocoding pattern as well. So I'm using ArcGIS Enterprise 10.6 here, but the map viewer tool was installed starting at 10.5.1. So 10.5.1 to current versions all have this tool in them. So I have a USA 30,000 records in a CSV. It's important to note that this is a portal workflow. So your data needs to be on the portal, and an output feature service gets written out to the portal. So you go to Analysis, find Locations, find the Geocode Locations from Table tool, select your input table, wait for your suggested field mapping, and this is where you could do multi-field or single field. My table has multiple fields, and that mapping looks good, so we'll choose an output feature layer. You can also choose an output CSV or Excel file, which basically looks like the original input appended with location information. So X, Y's, all sorts of, like the match address that it matched to, the score, so how good the match was, all sorts of additional characteristics that come back, attributes that come back from the locator service. So I'm going to do another quick time warp here. And in just about 4 minutes, we see 30,000 points on the map. So how would you automate this from a scripting perspective? So the recommended way to automate enterprise geocoding right now is the Geocode Locations from Table tool. So you would use the Python version of the GP tool, so arcpy.geocoding.geocodeLocations from table. Since this is a portal workflow, you'll need to call arcpy.signIntoPortal first. Then you'll add the input hosted table. So this currently works with hosted tables that are on your portal. So if you have data that you want geocoded, you could upload it as a hosted table, grab the URL, input it here, and automate your batch geocoding process. Your input locator needs to be a locator on your ArcGIS organization, so a URL to your already published locator, submit your field mapping, give it an output name, and then country, rooftop category, so all the optional geocoding parameters. So this was sort of a portal workflow. So all those inputs lived on the portal, and all the outputs got outputted to the portal. So now let's talk a little bit about an API that leverages this backend architecture for geocoding data on your local machine. So at 10.7, we introduced the GeocodeFile API. The GeocodeFile API is a REST endpoint that demands an input of a zipped file on the server and outputs the zipped file, makes the output available for the client to download. So you might ask, Victor, why are we using zip files? And the reason we're using zip files is because it's the fastest way to do an FTP transfer from your machine to a server. So it's the client's responsibility to grab your table, zip it up, send it to this, upload it to the server, and then the geocoding tool's GP service takes care of chunking, geocoding, retry logic, authenticates the request, gets the job done as fast as possible, and makes the geocode output available for you to use. That geocode output comes out as a zip file, but you can unzip it and retrieve the results on your end. So this accepts multiple different kinds of inputs. So a zipped GDB table, a zipped CSV, or a zipped Excel file. It outputs a zipped CSV, zipped XLS, or a zipped feature class. And then the client comes back and downloads the results. So it's up to the client to ask the server, hey, is my job done yet? Hey, is my job done yet? And once the job is done, the client downloads the results and presents them to the user. So again, this is an API-only functionality at 10.7. We're working on adding this as a GP tool in Pro 2.4. And so hopefully, starting at Pro 2.4, you'll just be able to call an ArcPy command, and it'll do everything for you. But if you want to get a head start and call the REST endpoint on your own, here's what, in Python, what some of this code might look like. So the first parameter is actually, the best way to do this is if you look at the GeocodeFile payload, that's sort of all of the parameters that we're going to send to the REST API. So the Geocode service URL, the output type you want. So the output type could be CSV, XLS, GDB. The input file, which is a zipped item ID on your server. The table name, so table name is if you have multiple tables in your Excel file, you could give it sheet 1 or sheet 2, and it would geocode just that sheet. Source country, output name, and then obviously you would pass the token because the portal needs to authenticate the request. So this, the geocode parameters is the only really complicated parameter. It's a JSON bag with a lot of different things in it, specifically the field mapping, what field type is, what file type is in the zipped file that I'm opening, all that sort of stuff. I've also omitted a bit of code as an exercise for developers, and that bit is submitting a multi-part post request to upload your zip file to the server. So you'll need to do that first, grab the item ID, input the item ID in the input file variable I have on the screen, and then you should be good to go. And if any of you have worked with asynchronous services before, you'll know that you'll need to write a loop like this that checks, hey, is the job done yet? Which basically says, if the job is executing, check if the status is Esri job succeeded. If it has succeeded, then go forth, download the results, dump them to somewhere on disk, and look at your geocoding results. Cool. So that was if we talked a little bit about if your data is in the portal. We talked a little bit about if your data is on your disk locally. And so the last kind of use case I want to talk about for leveraging this architecture that we had discussed is if your data is in a big data file share. So this is specifically if you have the GeoAnalytics extension and you have a table in your big data file share that you want as input to your batch geocoding operation. So the GeoAnalytics, if you have the GeoAnalytics extension enabled, you can open your ArcGIS Enterprise map viewer, and there will be a partner list of tools. So there's the standard analysis tools, and then there's the GeoAnalytics tools. So the GeoAnalytics tools has a similar map viewer experience called Geocode locations from table as well. And this input table is from a big data file share on your ArcGIS Enterprise organization. And this backend has all the chunking and retry logic built in that we had discussed. There are other ways to call the GeoAnalytics function. Another way is using the Python API. So the GeoAnalytics tool is exposed via the GeoAnalytics module in the Python API. This, again, this operation has all the chunking and retry logic built in, and it takes an input table from the big data file share in ArcGIS Enterprise. So a little bit about configuration. So if you do have the GeoAnalytics extension and are looking to use this tool, there's only really 2 real parameters that you can control. And they're the percentage max allowed compute cores and the percentage max allowed compute memory. And based on these 2 properties, your Spark deployment will geocode, get the geocoding job done using as many cores as it can. The place you would add these 2 properties specifically is whatever your machine name is, server, admin, system, properties, update. And in that update, in that JSON format, you would just add this JSON bag with those two properties, configure them to numbers that seem amicable for your system, and you should be good to go. And there's a doc link page there if you want to learn more about it. If you enjoyed my presentation, feel free to review me and take the survey. If you didn't, don't worry about this slide. That was a joke. Please do give me feedback. I give some flavor of this presentation at the UC and at the Dev Summit every year. I'm trying to make it better. So thanks so much for coming, everyone. And at this point, I'll take any questions you might have. So the question was, the new Create Locator tool in Pro, it doesn't require style sheets anymore. Is that true? Yes, basically. So it's less a style-based architecture and more a role-based. So depending on what your data is, you just define the role for your data. So if you have points, you would add that point feature class in and select point address and then map all the relevant fields. But if you had streets or line segments, you would maybe input that and select street address. So it's on a per role basis instead of style basis.
Will you be able to add in rules to language? Because that's how we control graphical recognition languages. So in the style sheet, we add rules there to do translation. So will you still be able to do that?
So the question is, we add specific rules in the style sheet for specific translations. Will we still be able to do that? I actually don't know the answer to that question. Rob might. Sweet. Any other questions? If not, I'll stick around for a while. Feel free to come up. I'll be here. Get my business card if you want to bother me. And thanks so much for coming, everyone.